So I want to start this with a little story about how I started my career as a programmer first. So when I started, I struggled a lot. I suffered from my own code, the code that I wrote, because it was, to be frankly speaking, it was not good. It was not good. It was not fit for change. It was spaghetti code. I was working for a small web development company, and we had the worst customers. Only when you showed them the first version, this is when they knew what they really needed. And then I wanted to change it all, right? And I had to change it all. And I suffered because it was so hard to change those things. Because when I had to change it, I not only had to change it in one place, I also had to change it in this other place, and in this other place, and in this other place in a slightly different way. And to make that change happen, I had to change 3 other things, and so on and so forth, right? It was poorly designed. I eventually ended up reading technical books about design and so on, and I developed a feeling about what customers might need. I got better at anticipating the changes they need, and I got better at design. But it still so happened that I ended up with code that was hard to change. It seems like it's the nature of code is that eventually it becomes hard to change. And I knew I had to improve it. But I was not sure if I could improve it. Nobody cared about the code, about the design and how hard it is to change. They only cared about whether it works or that it does what it's supposed to do. Nobody cared about the structure of the code. Only I cared about it. And I didn't know about refactoring, how to refactor safely and how to test it back then. I had design idea, but I didn't know about proper refactoring. So I knew I had to make this experiment in a safe space where I sit on my own terms with the code for as long as I needed, and to try and to slowly improve it so I can again change it more easily. And I had no idea if I would succeed in making that happen. I had no idea if this would be a success and I can actually improve it. I was not sure of that. It was a risk. I could break anything, everything. It was really risky to try that. And because nobody cared and they wanted the software yesterday, eventually I took the code home where I had the code and me on my own terms. I could take all the time I needed, and I could slowly walk through the code and try and improve it. And this, I mean, now, okay, we have to say that this is a bad thing. People shouldn't do this. People shouldn't need to do this. But for me, this was a huge relief because I was actually often successful doing this. And when I was able to do this, the code became much more easy to change. And I had a very easy life then at work after that effort. And I should have done it at work, of course. Eventually, later, I learned about practices that would help me to improve the design safely, with more confidence, like refactoring, and also test-driven development, where I would be able to improve the design of the code continuously whenever I wanted, and even without fear, which was great. So in November 2023, GPTs came out on ChatGPT. GPTs were a way that you could build your own agents, and they would run in the cloud, and other people could use it, and they could run Python code. So they could write Python code, and they could also run Python code. And for me, the obvious next thing was, I need to build a software crafter. I need to build an agent that does strict test-driven development, because this is something that really helped me. So I built this GPT, and it could solve simple katas like Roman numeral katas, Roman numeral kata, or other simple katas. Eventually, as the chat and the context grew, it started performing poorly. That was one of the limitations, but it kind of worked. It was fun. This was the system prompt back then. And I didn't recognize back then that this was something I would have a lot today. And today I would call this a process file, where I have in the top, I have the high level intent. Then I have some rules, and then I have workflow steps that the AI should follow strictly, step by step. Eventually, because the models weren't that good back then, and also we didn't know about like context engineering and keeping context small, and we didn't know so much about it. And then it didn't work so well. I thought, yeah, it's nice, it's a toy, but it's never going to get there. And then new models came out, and they weren't really better. And I thought like we're already hitting like the maximum, and we're not getting anywhere. But then eventually, like Claude Sonnet 3.7 and 4 came out, and they were really, in my opinion, much better, much more capable. And then I had to try it again. In the meantime, on February 2025, this guy, Andrew Carpathy, he coined the term vibe coding. And he said that we should go with the vibes. The models are now so good, we should just give them specification, what it should do, and then we should just let it write the code, and we should go with the code. We don't even care about the code anymore. This was like vibe coding. To me, this sounded strange. As I told you in the beginning of my talk, for me, it was always when I cared about the code, was when I was able to change it easily, and when I had a nice time, and when I had a sustainable software development going on. And frankly speaking, I think vibe coding is something we have been doing for a long time, and it didn't work so well, I believe. Later in May, Kent Beck wrote this article about augmented coding, and he put it in a different perspective. Like, yes, working with agents to write code, but also to have a say in what agents are doing, and also to care about the code, to care about the quality, to care about its design and its fitness to change, and its test, and so on and so forth. And this resonated with me much more because it's also what I experienced in my career, like how I managed to be successful. So I thought I need to try this. And I think software engineers, I don't know if some of you are working in software development. Is it? Yeah. I think like we are managers of complexity. I'm not sure, can you even manage complexity? Maybe we are just navigating complexity. But we have been this before AI. And I think we're still with AI doing that. And our goal is to make the systems that we build as simple as possible, that we can change it in a sustainable manner. So I had to choose a project that I want to build. And the project I chose to build was the code modernizer. The idea was, wouldn't it be cool if you had an agent and you could give it some legacy code, and it would analyze the legacy code, and it would break hard dependencies, and it would characterize it, it would cover it with characterization tests, so that it's fully covered with tests, and then it would help me improve the code. Or maybe it would already autonomously improve the legacy code, and it would make it more modular. It would make it easier to change for me and for AI. This is the thing I set out to solve. And upon lots of the things I do when I work on legacy code is I use refactoring tooling. But the refactoring tooling I use is either not open source or it is not built for user interface. So I had to build my own. And I started building refactoring tools with the agent for this code modernizer. That was the problem I set out to solve. I had to have some principles that I would follow to make it actually work. And one of the principles I had was Pokayoke. Who knows Pokayoke? Pokayoke is a term from lean manufacturing. What do you see on the screen? Do you recognize it? USB-C. Awesome. What is great about USB-C? You can put it both ways, exactly. That's what Pokayoke is you cannot get it wrong, and you design the system in a way that you cannot get it wrong. I wanted to design my system in a way that the AI could not get it wrong. It could not make a mistake. I wanted to describe everything I needed so that it was not able to make any mistake. Because usually it does make mistakes, unless you are very precise in what you tell it to do. And I think blaming is for the lazy. And following Pokayoke, of course, I had to do test-driven development. And I had to write a test first. Because to me, the test that I write is already the most precise way that I can explain to the agent what I wanted to build. Given I have a test, I can have AI write the code for the test. And the idea that the test is more important than the code is an old idea. It's not new. But I believe that now that we have AI and we can generate code, I think it's more clear now that tests are more important than code. Given I have a suite of tests and they cover all the code, and I have the code, if I had to decide which of the two I want to delete, I think I would delete the code. I can regenerate the code. And the tests specify what I wanted, and it's an executable specification. And also, we learned in the meantime that AI works best in small contexts. Like you wanna have a really small context, and then it works best. Not only does it work best, it's also cheapest. Small contexts are very cheap. So I had to try really hard to find the smallest problems I can solve one at a time. And I also learned that AI always wanted large batches. It was very hard to find ways to pick small problems through AI. Eventually, my strategy was that after I defined a goal together with AI, I would have it break this goal into smaller parts, like vertical slices. And then I sorted them by complexity ascending or simplicity ascending. I would pick the first item and I would say, let's break this apart even more into even smaller problems. And I had smaller problems to solve. And then I picked the smallest problem. It was still too large for me. I used something called then TDD zombies. It's a practice I learned with test-driven development is whatever you do, you start with 0 cases, and then eventually you go to the 1 case, and then you go to many cases. and so on and so forth. It's a trick to get even smaller in problems. And I used the very smallest problem here. And this was the one I then solved, first writing the test and then implementing it. Doing this, I always wanted to make sure I always keep the test working. And I mean the code working. Like I had then, given I always wrote the code, the test first, I had tests for all of the code, and I would have one button, and if I clicked it within 1 second, I knew if it works or not, and I wanted to always work. And if for some reason the AI made a mistake and it does not work, then I would just revert and go back and be more precise and try again. Okay? So I would try over a lot. I would revert a lot. So those were my principles to sum it up. Poka-yoke, small steps, feedback through tests and other things along the lines, test-driven development. But I also wanted to aim for higher autonomy. I wanted to have it like try and go on its own without needing me. About rules and processes and so on, like how I did this, I discovered some patterns I used that really helped me. And one of it I learned from a friend, Llewellyn, and it's called the starter symbol. I have these two lines in my rules file, and I will tell my agent to always start with this symbol, and then eventually a message looks like this. And I will have different symbols for different steps in the process. So from just looking at this symbol, I already know kind of what it's doing. It gives me a lot of information. And the other thing that's really great about it is just in case the context gets too large and the context starts drifting and the AI starts to forget things, I can see this emoji disappear. I know, oh, hold on, there's something going on, let's stop this. Context is too large. And revert. So it's giving me a lot of information. Another thing that I used a lot were process files, where in my development process, I had lots of different files describing what it's about. Again, high-level intent, I have a starter symbol and a few steps that the agent should follow when it works through this process. I would develop those process files. I would invent features only to throw away the features, just that I can try my process files. And I would run them, I would trial what the process files will output with this model. And if it made something wrong or something I didn't like, then I went back and I improved the process file. I exposed the decision. I made explicit what it should have done different in the process file. And so going this way, I would add more and more decisions into these process files. And eventually, the process files became large. They became too large. And then I had, again, issues with context size. I needed smaller context size. So what I ended up doing was I did split the process files. I tried to find coherent pieces or workflow steps in the process files that I could cut out, give it a new process file, a new name, a new starter symbol, a new purpose. And then I have many more process files, smaller ones, and so on and so forth. But if I have many process files, now how do I get from one process to the next process? How do I make AI follow this process and then this other process and then this other process? It always needs me as the human in the loop. And this was kind of boring. So I eventually learned something called sub-agent. I could add a step in my process file in the very end to spawn a new agent, a fresh agent with a fresh context to work on a different process. This way, I could have one process doing some work, then it spawns another agent doing some other process, doing its work, spawning another agent, doing its process, doing its work, and so on and so forth. Each agent would start with a fresh context. Context would go smaller, of course, and then I would have something like a task chain. They would run in a chain, and each had a small context. They would even run in a loop. But of course, agents need context. They need to understand what they are building, what it is they are working on, and they need to be aligned on the goal, and they need to share some information. So what I did there was I used Markdown where I put this information. For example, I would have a goal Markdown file where there is like a high-level description of the project, what we are working on. Maybe there were some decisions that were made, like the outcomes of that decision. Maybe there was some architectural information, and then there was the next story we are working on, and the next tasks that we need to be working on. So, and maybe it would also read the README file of the project, have an understanding what the project is about. So each agent would get all the necessary information from some Markdown. Given I had like a chain of agents running, what was annoying to me was that each agent also had the responsibility to delegate to another agent. This delegation is one step that is unnecessary for an agent. An agent should only do its work. It should not have to delegate. So I ended up trying to extract orchestrators. I tried to find places in my workflow where I could extract one agent that only delegates to other agents, and they only did its work. And that worked quite well, actually. And it was a much more robust a workflow, in my opinion. If something went wrong, it was easier for the agents to get back on track, to recover from this issue. One example I would like to give is the refactoring orchestrator. Is just an example. I have a much larger one now. Is in the beginning, I start a new sub-agent for analysis, and this sub-agent only has the job to find something we can improve in the design, and then it should report back the analysis. And in the second step, the orchestrator starts another sub-agent to analyze how we need to decompose this improvement into small refactoring steps and report back the refactoring steps. And only in the third step, the refactoring orchestrator would, for each refactoring, spawn an agent, a sub-agent, that would execute the refactoring. It would run the test first, make sure that the Git is in a clean state, then do the refactoring, then run again the tests, and then commit it with a proper message. Yeah, this is one example how I would do orchestrators. And given you have such a workflow, you are inclined to walk away from the computer. I remember once I had it running for 2 hours, and it was working on extract method refactoring, and it did like 60 commits. It didn't need me. When you go away, what if something goes wrong and it can't continue? Maybe it stops, or maybe there is something unexpected happening. Maybe the git status is not clean and it doesn't know what to do with those files now. A pattern I learned that helps doing that, solving that was wake. For example, you can play a sound that when you walk away and you hear the sound, that's when you go back to the computer. Or you could even use text-to-speech. First, I used this very basic Python text-to-speech, which is god-awful. When it talks, you have no idea what it's even saying. Later, I used a Piper TTS. It's a very small text-to-speech model. It works much better and is very performant. But I also learned that I do not recommend walking away. I do not recommend it. What I rather recommend is to stay there, to watch what it's doing, and to hold the finger on the stop button. So that when something goes wrong, you can stop it. And because you want to stop it as early as possible, if you stop it too late, you will have to do all the rework. So you want to stop it as soon as possible that the rework is small, or you don't have any rework at all. And you pay for tokens, yeah? So, for example, you could have checkpoints. Whenever there is a significant point, you want to be there and to review it, add that to the workflow. Say, okay, in this point in time, I want to be asked to review. I learned that AI is really good at asking clarifying questions. Like in the beginning of my process, when we align on the goal, I have it ask me clarifying questions. And it's really good at doing that. And those questions really nail down what it is that we want to build. This is the workflow I have so far. It's like 120 something nodes. The AI is running through autonomously, can run through autonomously, working on some goal, following test-driven development. What I learned doing this is, first of all, I think you want to algorithmify everything. I don't want to say automate because like working with AI is already kind of automation. I think what we want to do is like put everything there is that we can put in a script, for example. Like I have a script that gives me code coverage. I have a script that can run mutation testing. I have a script that runs a test for it. I would like to have a script for anything that the AI wants to do. And when I write those scripts, I really recommend to distill this standard out. I often see people, they have their cursor open or whatever, and they have AI run the tests, and then there is a ton of log output contaminating the context. And the AI has to read it all, and of course, it fills the context, and of course, it is expensive, and the AI starts performing worse when it has to read all of those log lines. But it doesn't need to. We can just create a wrapper script that filters out all the unnecessary details and only leaves in what is really important and feeds the AI only what is actually needed. Another thing that worked really well, and I can tell you a real story of a real product I'm actually working on. This happened like, I think 2 months ago, is we had a customer incident reporting a deadlock where they couldn't log in to the system in a certain state of the application. It was only one customer, wasn't too bad. And we started analyzing it, but it was very hard to analyze, and we didn't come up with a solution. Our only idea was that we have to change the architecture to solve this. But then more and more customers reported the same incident, and we looked into it again, and we tried for weeks solving it, but we couldn't. Eventually, I thought, okay, I need to try and use AI to solve it. So I went to Claude and I asked it, hey, this is my deadlock. This is the code. This is where it happens. This is all information I have about this deadlock. Please fix it. And Claude analyzed the code. It read some files, and then it said, yes, I know what's wrong. I understand it, and I know how to fix it, and I will fix it for you. And it changed some files, and then it said, now it's fixed. You can imagine what happened. I tried reproducing it again, and I reproduced the issue, and it was still there. And I thought, Claude, look, you didn't fix the issue. There is still a deadlock. It kept analyzing. It read some files. It did some thinking, and then it said, oh, now I understand the problem, and now I can fix it. And it again changed something in the code, and it said, but now I fixed it. So I again started this thing. I tried to reproduce it, and the problem was still there. So I started a fresh context and started over. Almost the same thing repeated, and I tried like 5 times, but we didn't get nowhere. We only changed the code in some arbitrary way, not fixing anything. So I thought, this is going nowhere, we have to try something else. So what I did was, I told AI, so let's not change the code, let's come up with an hypothesis of what's the problem, and then prove the hypothesis. And what it did then was it analyzed the code, it read some files, and then it came up with an hypothesis. And then it said, I want to prove the hypothesis. So it added log output, like console log statements all over the place where it needed them. And then I ran the application, I reproduced the deadlock. I gave it the log output it wanted. And then it said, oh, I have disproven my hypothesis. I was wrong. But I have another hypothesis, and it added more log output. And I ran it again, I reproduced the issue. I fed it back the log output, and then it said, oh, I have proven my hypothesis. I know how to fix it. And it made some changes. And I was really curious now. Now, I did run it again, and this one deadlock was actually fixed, which was incredible. But there was still another deadlock at a slightly later, different position. So it created a hypothesis, added some log output. I fed it the output. It proved its hypothesis. It wanted to fix it. It fixed it, and it was fixed. The AI fixed it. It turns out AI is really good at debugging. And I want to use it a lot for debugging. Another thing that worked really well for me is, I call it ask, don't tell. Often when working with AI, we are used to telling it exactly what to do. We think like we know what we want and what it should do, and we know the right way, and we tell it. But we are not always right. And also we don't know what we don't know. And sometimes it's really helpful if instead of telling, the AI is to ask it. Ask it, do you see this problem? What could we do about it? Don't change any code, just tell me what could we do about it. And it sometimes gives you a surprising answer, and you might learn new things that you haven't thought about. And you will learn new things. That's really great. Another thing that really happened for me at work is I work a lot with legacy code, because this is one of my expertise is working with legacy code, refactoring and so on. Also, I like it, I enjoy it, because it's a challenge. Is often legacy code is quite complex, and it doesn't have tests, and it's hard to test. And you first have to make refactorings to the code so you can actually test it. And then it is very risky to make those improvements. And when I work, I usually do very small refactorings where I only change 3 to 5 lines, and then I commit it. And then I change 3 to 5 lines, and then I commit it. And I separate my refactoring commits from my behavior changing commits. So if I change something in behavior, if I implement a new feature or I fix a bug, there's a different commit notation than when I do my refactorings. And I noticed AI is really good at reviewing refactoring commits. So what I ended up doing was I made a small refactoring, 3 to 5 lines. I had no tests for this. It wasn't automated. I did it manually on my own. And then I taught Claude, hey, can you please review my code and warn me if I have a change in behavior? It analyzed my code, it gave me feedback. And I kept doing this. Change some code, ask it to review it. I even created a slash command for doing a refactoring review. Now I realized that this is so powerful. I can even go back to commits I made months ago and review them for bugs I made in my refactorings. I can find bugs in my refactorings I did months ago, given I have this idea now. I even created a script that would find me all refactoring commits. I would have a slash command that would spawn parallel agents analyzing refactoring commits. And it's overly defensive reviewing those. If it finds something it thinks might be a change in behavior, it usually says, this can be null. You don't care for that case, or it can be null. And then I ask it like, but can it really be null? And then it searches through the reference and finds out it cannot be null. And it said, oh, okay, it's fine, no change in behavior. So it's overly defensive, which is also good. Limitations. So far, I haven't figured out a way to make it be good at design. To achieve a design that is easy to change in the long run. I have in my workflow, I have a refactoring step, a long refactoring process. And whenever I get there, I feel uneasy because sometimes it over-engineers, or sometimes it finds ways to make the code worse in unexpected ways. And I have not yet solved that issue. I'm wondering if or when we will be able to solve that issue, or at all. And in how many years, I don't know. Also, I noticed it's really biased. It always wants large batches. It also tends to overdo it. For example, I was working on the slides. I wanted to make some image bigger. I mean the code section bigger, and I asked it to create styles for this. And for some reason, it not only created large, it also created extra large. I did never ask for extra large. So it's overdoing the things I ask it for. Always, it thinks I am right, even if I'm not. It also thinks it is always right. So there are a lot of biases, and we have to work around those biases. I also recognize that it is addictive. I read like this was so fun working with it and getting it to write code autonomously. Like I would sit long evenings for many days, and I had like maybe crap result, amazing result, and this was like a dopamine hit. And then again, like crap result, amazing result, dopamine hit, right? It's like it was a bit addicting. It was even like science fiction, yeah. I found this blog post the other day. I really like it. It's called the false mastery trap. So I had never written refactoring tooling before with Roslyn. I'm not an expert in this, but I was able to do it through AI. And when I do this, and I can do it, and I get success out of it, it feels like mastery. But it's not true. I'm not a master there. Maybe I'm only 80% there. But what is with the other 20%? Maybe it's not solved yet. Also, when you can use AI for something and you start using it, you just don't want to pick it up anymore, do it yourself. It's so hard to pick it up again when AI can do it for you. And yeah, I think we still have to practice. There were these three things that that are really crucial for me in software engineering. That the three steps, maybe you have heard about them. The first is to make it work. And AI is really good at making it work right now. It's really good at this. Second is make it right. Not so much. I have not succeeded with it. And the third one is make it fast, but only and only if you really have to make it fast. We haven't. In my opinion, we haven't gotten past two. We have solved one, but we are not there yet. That's my conclusion, actually. I recommend. Yeah, hold on. I recommend. So if you haven't already, try and build your own agent. I did this, and it was a lot of fun, and it taught me a lot. It gives you a better understanding, like what is going on behind the scenes, what is going on with tool calls and MCP, and what is it doing. It's very simple, very few lines of code to get an agent up and running. It's very easy to do. And I learned a lot doing it. And if you do it, if you try and build an agent, please don't put it in a box of JSON like we do it with MCP. I feel like this is a very interesting decision to use JSON because not only does it use a lot of tokens, also JSON does not support multi-line strings. So the LLM has to encode all of its multi-line strings and code into a single JSON string. There's a lot of effort. And then we decode it again. I think it's a little bit wasteful. But it's amazing to me like how this actually works and how we can have billions of requests every day, having LLMs encode and decode the JSON messages with multi-line strings in them. And it works reliably. I think there are better formats for this out there. And I think we need to still learn and practice software engineering essentials. And the ones that helped me a lot were like test-driven development, refactoring, and design. I have a few book recommendations I would like to give. The test-driven development by example by Kent Beck is for me the best book on TDD. The refactoring book, it's a second edition already, I've read both, by Martin Fowler. It has JavaScript examples in it. It's like he invented the term. It's a very crucial practice, and it's a very good book. I also really like the Modern Software Engineering book by Dave Farley. It's an amazing book, and it really gives you everything you need to know about modern software engineering. It is very recent. And Vlad made a tremendous job at putting everything we have as knowledge about design, about coupling, and modularity and cohesion in this book. It starts being maybe a bit boring, but it gets much more interesting later. It's like a collection of everything you need to know about design. I mean, Of course, there is more out there, but this is a good starting point, I think. And if you read and follow these books, eventually you don't have to read this book. And because my company will pay for driving here, I want to share this link. Transcendis is hiring for senior lead software engineers and principal architect whatsoever for AI and stuff. I'm Gregor. And I don't have a name for this talk. So if you have I want to change it. If you have a good suggestion for the name of this talk, please let me know.